Welcome to the third video lecture for ENSC 2613. Today we will cover series and parallel combinations. A series combination is when you have two or more items in a single branch. All of the current that travels through one must travel through all of the items. For example, when we have these three 20 ohm resistors in series, we can combine them by simply adding their values together, and you have 20 plus 20 plus 20 is equal to 60. For parallel combinations, all of your components must be connected between the same two nodes. For instance, all three of these 30 ohm resistors are connected to nodes A and B, and we can calculate the equivalent resistance by taking the inverse of the sum of the inverses, or 1 over 30 plus 1 over 30 plus 1 over 30 to the negative 1, which gives us 10 ohms. Now sometimes they're not in series or parallel right off the bat. You have to do some steps in between. Whenever you have a series and parallel combinations to deal with, the best method is to always check for series combinations first. And in order to do this, we need to look at all of the nodes. For instance, you can see here that the blue node is a single branch, and so that means the top two 10 ohm resistors are in series. We can combine them by saying 10 plus 10 is equal to 20, and once we've combined those, we can see the two 20 ohm resistors are now in parallel between the red and green nodes, and 20 in parallel with 20 is equal to 10. Okay, in this example, we have to again look at all of our nodes first, but none of them are in series because they all branch in multiple directions. And so we will then check for parallel next, and you can see that 10 is in parallel with 40, and the 24 is in parallel with the 24, and those can be combined to make 8 and 12 respectively. And then you have a single series connection, and you have 8 plus 12 is equal to 20. Okay, and then moving on to the third problem, we, just like always, look at all of our nodes, and we check for a series combination first. You have a single branch between the 10 and 20 ohm resistor, so that must be a series connection, and 10 plus 20 is equal to 30. After you make that combination, we'll check for parallel, and we have 30 in parallel with 30 is equal to 15. After we make a parallel combination, we check for series again, and that gives us 25 plus 15 is equal to 40. And then our final combination is 40 in parallel with 40 is equal to 20. Here's a bonus problem for you guys to try to work on your own. I will provide the answer so you can see if you're doing it correctly. If you're having difficulty working out these problems, please contact your instructor or teaching assistants, and we'll be happy to help you. Come back next time and we'll cover the voltage divider rule and the current divider rule.